This is just me working out all of the problems on the Just Differentiated worksheet. I think it says at the very top to do your work on a separate piece of paper, but I'm going to attempt to do my work inside these little boxes because I don't need you to simplify your answers. I just need you to come up with the derivative. Okay, so let's go ahead and get started. So number one, f prime, and I'm not even going to write f prime of x. F prime equals 5. Okay, number two, f prime equals, so the derivative of x squared is 2x, and the derivative of 3x is 3, and the derivative of negative 4 is 0. So number 3, v prime of r is equal to, bring the 3 out front, multiply it by the 4/3 that's already there, and the pi that's already there, and then just subtract 1 from the exponent. Okay, that's what I mean by not simplifying. Okay. Number 4, capital F prime is equal to, bring the 3 out front, multiply it by what's inside, subtract 1 from the 3, and then multiply that by what's in the derivative of what's inside. So the derivative of the outside, which is this guy here, multiplied by the derivative of the inside. Okay. Next problem, y prime. Let me get my purple back. So y prime equals, again we have the outside function as a power function. Bring the power out front and multiply by what's inside. Subtract 1 from the power. Be careful. Just say to yourself while you're doing this, negative 9 minus 1, and negative 9 minus 1 is negative 10. I can't tell you how many people put negative 8 there. Negative 9 minus 1 is negative 10. Okay, but then don't forget, we have to multiply by the derivative of the inside, and the derivative of the inside is, derivative of 6t is 6. Now, for the next one, I like to actually rewrite my my function in terms of something to a power. I don't like to have to take the derivative of the square root of something. So I'm going to rewrite my function as 5x to the 1/2 power. And if I write 5x to the 1/2 power, then it reminds me that I need to take that 1/2, which is the power, it's the outside function, and multiply it by the inside, raised to the 1/2 minus 1, so negative 1/2. And then I have to multiply by the derivative of the inside, and the derivative of the inside is 5. Okay, I don't worry about that. Next problem, let's see, how do I want to do this? I could multiply it out, and that's probably a good idea. I've got a little space over here to the right, so I'm going to go ahead and multiply that out. It'll be easier to do that. The next one I will not multiply out. Anyway, using the FOIL method, y squared times 2y is 2y cubed. Think through everything you do. It's so important because you want to make sure you get all the easy ones right, and if you make silly mistakes on the easy ones, then you're kind of starting behind the 8 ball. You don't want to do that. Minus 7y squared, so outsides together and then insides together, plus 2y, and then last times last is minus 7. Okay, so here we have at least a better version, let's say, of that function, and then the derivative of that function, which would be capital G prime, would be equal to the derivative of the first term, which would be 6y squared, and then minus 14y, the derivative of the second term, and then we have plus 2, and that's it. Okay, obviously you could have just used the product rule on that, which is exactly how I'm going to do this problem here. Okay, the h prime in this next problem, oops, what did I do? Oh man, are you serious? Okay, there, got it back. Alright, capital H prime is equal to, and we have the product of two functions. So I'm going to take the first function and rewrite it, x cubed minus x plus 1, and I'm going to multiply that by the derivative of the second function. And the derivative of the second function, which is negative 2 times x to the negative 2 minus 1, which is negative 3, and then minus, I can see minus because that negative 3 times the 2 is negative 6, x to the negative 3 minus 1 is negative 4. Okay, do I have room here? It looks like I do. Alright, and then plus the derivative of the first function, which the derivative of x cubed is 3x squared. Remember, the derivative of the sum of any functions is just the sum of the derivatives, okay? And then plus the derivative of negative x, which is minus 1 or negative 1. And then we're going to take that derivative and multiply it by the second function, which is x to the negative 2 plus 2x to the negative 3. Aren't you happy that I'm not making you simplify any one of these? Okay. Next problem. We have the derivative of a quotient. So h prime is equal to low, x minus 1, d high, and the derivative of x plus 2 is 1, minus the high, which is x plus 2, multiplied by d low, or the derivative of the denominator, which is 1, over low squared, x minus 1 squared. Okay? Maybe I'll change colors on you here for the last problem on this, on my screen anyway. H of x, you know what? I'm going to rewrite this. I don't want to use the quotient rule. In fact, I'm going to use the quotient rule as little as I possibly can. So what I'm going to do here is I'm going to rewrite this function as x to the fourth plus x squared plus 1 to the negative 1 power. Okay, and so by doing that, then I can just use the power rule, chain rule, power rule. And so anyway, h prime is equal to the outside function, which is negative 1, multiplied by the inside function, which is x to the fourth, plus x squared, and then plus 1. Isn't that nice? And then we also have to multiply, though, by, hold on a second, I didn't subtract 1 from my exponent, I see it. Alright, negative 1 minus 1, and instead of writing negative 1 minus 1, I'm going to back that up and just write negative 2. Okay? I almost missed that one. And then I'm going to multiply by the derivative of the inside. So I had the derivative of the outside, and the derivative of the inside is the derivative of x to the fourth, which is 4x cubed, and then plus 2x. And the derivative of 1 is 0, so we are done with that problem. Of course, there's obviously other ways to show that answer. So that's the first 10. I think I have 10 more. I'm only looking at the top half here. That's why I said that. Okay, time in f prime, number 11, is equal to 1 minus, so the derivative of x is 1. The derivative of negative 3 sine x is negative 3 cosine x. Okay, number 12, y prime. The derivative of sine is cosine, and the derivative of cosine is negative sine. Okay, 13, we have g prime of x. G prime is equal to, we have the product now of two functions. The first, which is t cubed, multiplied by the derivative of the second, which is negative sine of t, plus the plus the derivative of the first, multiplied by the second, cosine of t. Okay. 14, we see a quotient, so y prime then is equal to low d high, and the derivative of the tangent of x is secant squared of x, minus high tangent of x, multiplied by the derivative of x, which is just 1, and then we write that all over low squared, which is just over x squared. Okay. Now 15, we get y prime is equal to the product of two functions. Can we simplify this a little bit? Cosine over sine squared. Let's just leave it at that. The first function, which is cosecant of x, multiplied by the derivative of the cotangent, and the derivative of the cotangent is negative cosecant squared of x. I was going to think through that. Okay, yeah, that's right. And then plus the derivative of the first function. Remember, see the negative. The derivative of every trig function, whether it be regular trig or inverse trig, is going to be negative. Okay, so the derivative of cosecant of x is negative cosecant x, cotangent of x. Remember, cosecant and cotangent are forever linked. Okay, so that's the derivative of the cosecant, and then we multiply that by the second function, which is the cotangent of x. Okay, so that's that. what's next? Number 16, y prime is equal to, alright, so we have something to a power, and that power, bring that power out front, and we multiply that by what's inside, that x squared plus 4x plus 6, and then we have to subtract 1 from that power, so we get 5 minus 1 is 4, but then we have to multiply by the derivative of the inside, so keep saying those kinds of things to yourself. Derivative of the outside, got that, plus or multiply by the derivative of the inside. Okay? And then 17, y prime. So here we have, hopefully, it's an obvious outside function cosine, so the derivative of the cosine of anything is a negative sine of that anything. And that anything in this case happens to be a tangent of x. Okay? And then we have to multiply by the derivative of that anything. Okay, in this case, again, the derivative of the outside is negative sine of the inside, multiply by the derivative of the inside. And the derivative of the inside is the derivative of tangent of x, which is secant squared of x. Okay? So just like up there on one of those previous problems, on number 18, I don't like to take the derivative of the square root of something. So I'm going to rewrite this guy in terms of something to a power. So we have what's under the radical is the sine of x, and that square root means that sine of x is being raised to the 1/2 power. Okay, and so number 18, we see that y prime is equal to 1/2. We get to use the power rule now. 1/2 times what's inside, which is the sine of x, to the 1/2 minus 1, which is negative 1/2, and then we multiply that by the derivative of the sine of x, which is the cosine of x. So again, derivative of the outside multiplied by the derivative of the inside. Okay, almost done. We have capital F prime of x is equal to, so we have something to the 7th power. So we have 7 times x cubed plus, sorry, I lost my train of thought for a second. So we have the power times the inside to the power minus 1, so 7 minus 1 is 6. And then we multiply by the derivative of the inside, which is 3x squared. Derivative of x cubed is x squared, 3x squared, and then plus the derivative of 4x, which is 4. And we are almost there. Y prime here on number 20. So we've got a lot to write in this little tiny space, so I'm sorry that I think there's going to be some writing down there at the bottom of your screen. So hopefully you'll be able to see it still. The derivative of the product is the first function, again, which is here in this case 2x minus 5 to the 4th power, times the derivative of the second function. Well, we have a power here. We have to use the chain rule in that derivative of the second function. So let's use some brackets. Okay, so we have negative 3 multiplied by the inside, 8x squared minus 5. Okay, and raising that to the negative 3 minus 1, which is negative 4. Okay, but don't forget, we also have to multiply that by the derivative of the inside, which is 16x. Okay, so that's a big mess, that one right there. And can we get this in there? I don't know if you're going to be able to see this. Maybe I'll write it up a little bit so you can see it. Okay, I think there's some stuff blocking the screen down there. Alright, so that takes care of the first function multiplied by the derivative of the second function. Okay, but now we have to add to that. I'm going to go up here. We're going to add to that the second function, which I think I've been doing it derivative of the first. So let's do that. Multiply or add to that the derivative of the first function. The derivative of the first is 4 times 2x minus 5, and raising that to the 4 minus 1, so to the 3rd power. And then when we're going to multiply that by the derivative of the inside, and the derivative of 2x minus 5 is 2, and then we have to multiply that by the second function. So we have 8, I think we'll be able to fit it in, x squared, 8x squared, and then we have minus 5, and that all gets raised to the minus 3 power. So that took almost 15 minutes, so I need to make sure I keep my videos under 15. Hopefully that helps.